When working with Python, especially in a cybersecurity or automation context, one of the first professional habits to adopt is the use of virtual environments. This chapter explains what a virtual environment is, why it is essential, and how to create, activate, use, and deactivate one on your machine. What is a virtual environment? A virtual environment, often called a virtualenv, which stands for virtual environment, is an isolated folder on your computer that contains its own Python interpreter and its own set of installed libraries. It acts as a self-contained workspace, completely separate from the global Python installation on your operating system. When you install Python on your computer, it creates a global installation. Any library you install globally using the pip command, pip stands for pip installs packages, the standard Python package manager, is placed in a shared directory that all Python scripts on your machine can access. This may sound convenient, but it quickly creates serious problems in practice. Why is isolation important? Imagine you are working on two different Python projects at the same time. The first project is a web scraping script that requires version 1.5 of a specific library. The second project is a network scanning automation script that requires version 2.0 of the same library. These two versions are incompatible with each other. If you install one globally, the other project will break. This type of conflict is called a dependency conflict. In a cybersecurity context, this problem becomes even more critical. Security automation tools, penetration testing scripts, and exploit development frameworks each rely on very specific library versions. A version mismatch can cause a script to behave unexpectedly, produce incorrect results, or simply crash at the worst possible moment during a security audit. Additionally, installing libraries globally can pollute your system Python installation over time, making it harder to maintain, share, or reproduce your work environment. When you hand over a script to a colleague or deploy it in a pipeline, you need to guarantee that it will run in exactly the same conditions as when you developed it. Virtual environments solve all of these problems by creating a clean, isolated, and reproducible Python workspace for each project. How does a virtual environment work technically? When you create a virtual environment, Python generates a new folder in your project directory. This folder contains a copy, or a symbolic link, of the Python interpreter, a copy of the pip package manager, an empty site packages directory, where future libraries you install will be stored, activation scripts for different operating systems, Windows, Linux, Mac OS. When you activate the virtual environment, your terminal, also called a shell or command prompt, modifies its internal path variable. The path variable is a list of directories that your operating system searches through to find executable programs. By placing the virtual environments directory at the beginning of this list, your terminal will use the isolated Python interpreter and the isolated pip instead of the global ones. Any library you install after activation goes exclusively into the virtual environment's site packages directory, not into the global installation. This mechanism is completely transparent once you understand it. You simply activate the environment, work normally, and deactivate it when you are done. Creating a virtual environment. Python 3 includes a built-in module called venv, short for virtual environment, that allows you to create virtual environments without installing any additional tool. This is the recommended and most widely used approach. To create a virtual environment, open your terminal, navigate to your project folder, and run the following command. Python 3 mven nom_environment. For example, if you are working on a port scanning script and you name your environment mv_scanner, the command would be Python 3 mvenv_scanner. This command creates a folder named env_scanner in your current directory. You can name this folder anything you like, but common conventions in the professional world are env, venv, venv, or a name related to your project. On Windows, if your Python executable is registered simply as Python and not Python 3, the command becomes Python mvenv_scanner. Activating a virtual environment. Creating the environment is not enough. You must activate it before using it. Activation is what tells your terminal to use the isolated Python interpreter and pip. On Linux and Mac OS, the activation command is source env_scanner/bin/activate. On Windows, using the command prompt, also called CMD, the command is env_scanner/scripts/activate.bat. On Windows, using PowerShell, the command is env_scanner/scripts/activate.ps1. After activation, you will notice that your terminal prompt changes. It now displays the name of your virtual environment in parentheses at the beginning of a line, for example, env_scanner, user at machine:\project/scanner$. This visual indicator is very important. It tells you at a glance that you are working inside the isolated environment. Any pip install command you run from this point will install libraries only inside this environment. Installing libraries inside the environment. Once your environment is activated, you install libraries exactly as you would normally, using pip. For example, to install the requests library, a popular library for making HTTP requests, widely used in web security scripting. Pip install requests. Or to install a specific version of a library, for example version 2.28.0 of requests. Pip install requests == 2.28.0. These libraries are installed exclusively inside your virtual environment. If you open a new terminal without activating the environment, or if you work in another project, these libraries will not be accessible. You can verify which libraries are installed in your active environment at any time using pip list. This will display all installed packages and their versions within the isolated environment. Deactivating a virtual environment. When you have finished working in your project, you should deactivate the virtual environment to return to the normal state of your terminal. The deactivation command is the same on all operating systems. Deactivate. After running this command, your terminal prompt returns to its normal appearance, without the environment name, and any Python or pip commands will now use the global installation again. The requirements.txt file. Sharing your environment. A critical professional practice closely related to virtual environments is the use of a requirements file. A requirements file, conventionally named requirements.txt, is a plain text file that lists all the libraries your project depends on, along with their exact versions. To generate this file from your active virtual environment, run pip freeze >requirements.txt. The pip freeze command lists all installed packages with their exact versions. The greater than symbol followed by the file name writes this output into a text file. For example, a typical requirements.txt file might look like this. Requests == 2.28.0. Cryptography == 38.0.1. Paramiko == 2.11.0. This file allows anyone who receives your script, a colleague, an automated deployment system, or a security testing pipeline, to recreate the exact same environment with a single command. Pip install r requirements.txt. The r flag tells pip to read the list of packages from the specified file and install them all. This guarantees full reproducibility of your work environment. Virtual environments in a cybersecurity context. In cybersecurity and DevSecOps work, virtual environments are not optional. They are a standard professional practice. Here are concrete reasons why. Security automation scripts, for example, a script that uses the Paramiko library to automate SSH connections for auditing, require specific library versions that may conflict with other tools on the same machine. Penetration testing tools developed in Python, such as custom exploit scripts or vulnerability scanners, must be fully reproducible. A security audit conducted with one version of a library must be reproducible with the same version weeks later to validate patches. In a secure delivery pipeline, such as a continuous integration and continuous delivery pipeline, each automated test step runs in a clean, isolated environment created from a requirements.txt file, ensuring that no unexpected library affects the security test results. When sharing code with a security team, a virtual environment combined with a requirements.txt file ensures that all team members run the exact same tool versions, eliminating the "it works on my machine" problem. Common mistakes to avoid. There are a few common mistakes beginners make when working with virtual environments. Forgetting to activate the environment before installing libraries. If you run pip install without activating the environment, the library will be installed globally, defeating the entire purpose. Committing the virtual environment folder to version control, for example, to a Git repository. The environment folder can be very large and is specific to your machine. You should add the environment folder name to your gitignore file so it is excluded from version tracking. The requirements.txt file is what you share, not the environment folder itself. Creating the virtual environment inside a system directory. Always create your environment inside your project directory, or in a dedicated directory for environments. Using different Python versions inconsistently. If your project was developed with Python 3.10, make sure the virtual environment is also created with Python 3.10. You can specify the Python version when creating the environment like this: Python 3.10 venv_scanner. Summary. A virtual environment is an isolated Python workspace that prevents dependency conflicts, ensures reproducibility, and keeps your global Python installation clean. You create one with the ven module using the command python 3m ven_name. You activate it with a platform-specific activation script, which modifies your terminal search path to use the isolated interpreter and package manager. You install libraries inside it using pip, generate a requirements.txt file with pip freeze, and share this file so others can reproduce your environment. You deactivate the environment with the deactivate command when you are finished. In a professional cybersecurity and DevSecOps context, working without virtual environments is considered bad practice, as it undermines the reliability, security, and reproducibility of your work.